So good morning, everyone. I welcome you all to the third session of the SQL learning with a real life use case. And I am happy to have this session for the third day. And today we are going to learn interesting. I hear some echo. Can everyone mute their audio? So I hear a lot of background noise. So thank you for muting your audio. Okay, so today we are going to see, so we are here. So we are going to create DDL. So far we have seen what are the database fundamentals. We also learned about what is a SQL table basically, how it stores in the form of fields and records. And we also went through the requirement of the case study. So because this presentation we are going to we are going to use the case study to build that. Okay, and then for the use case, for the restaurant use case, we created a data model yesterday. So today we are going to create a physical data model, and we are going to create a physical structure. So today we are going to start with our coding. Okay, so today we are going to start with coding, because some of you would have seen, okay, why I'm not opening up SQL Management Studio, or I'm not starting with the SQL statements, because we were going through the requirement and design yesterday and day before yesterday. Today we are going to start with the coding. Okay, and then this is what the 15 days program, and today's specific agenda is we are going to learn about various data types that are available in Microsoft SQL Server, the important ones. And then we are also going to learn about constraints. What does constraint mean? Okay, what is the benefit of having constraint? And then we are going to finally create a table structure for our case study. And then as usual, we are going to have a quiz, and then look at the case study progress that we have made. So before starting today, also I want to again reiterate, I want to share again for the benefit of people who are joining for the first time. So the case study we have taken for this training program is building a restaurant application. Okay, building a restaurant application. So the requirement here is a chain of restaurant wants to build an application to capture, store, process and report their daily business transaction. Okay. So the system should capture customer visits, order details, what item the customer is ordering, and also the whole list of menu items. Right. So this is what the basic requirement from the restaurant owner. So ultimately he is looking for the system to answer some of the business questions like, okay, so what is the most ordered item in a month, or frequently visiting customer, items ordered together, and what time of the day, no, what item is selling, right? What day of the week, which item is selling high. So those kind of analysis he wants to see at the end. So for this, we have built a conceptual data model. I think this is what we built. You guys would have seen. This is the conceptual data model we have built. So we identified 5 entities. We need to have restaurant, and then we need to have a customer. We also need to have an item entity for holding the menu card items, all the list of items. Basically these two are more of a master table, and customer is also kind of master table, but a customer might have new customers on a daily basis, but still this is also a master table. Okay, and then the actual transaction tables are order header and order item. We also understood why we did not create a single order table, why we are creating order header and order item, right, with the example that we have seen yesterday. Because in order, if you see the invoice, it has item, it has the bill date, invoice date, it has what time they generated. All the information is more of a header level information, only one information is there. But there are below we saw item has various items, right? So you would have ordered 3 items, 2 items you would have had, and then coffee. So like that, one order will have multiple items. So that's why we have separated them into 2 separate entities. Okay, so this diagram represents one to many relationship. One restaurant will have many orders placed. One customer will order multiple orders, right? As he comes today, he will order one. Maybe if he comes again next visit, every visit he orders one order. Okay, and then so all the items in the menu card For every item there will be multiple orders, right? So different customers would have ordered. Similarly, one header will have multiple items. That's what we are representing here with a one to many relationship. That is called cardinality. Okay, so I'm just reiterating, that is called cardinality. And the details, the lowest level of information that gets stored in a table is called granularity. Okay, granularity and cardinality is what we learned yesterday. And finally, this relationship is enforced through something called referential integrity in database. It is called a foreign key, right? So through foreign key, we kind of enforce the relationship. So how, what we are going to enforce? So an order can be placed only. So an order item can be placed only for the item which is available in the menu card. Okay, so that's what this item will be created. So in the order item table, the order item can be created only for the valid items which are present in the item table. So order item can be created only for the valid order. Okay, so like that we have created logical data model with the data minimum data elements in it, right? Minimum fields in it. And also we have identified what is the primary key, uniquely identifying a record for each of the entity. So order ID is the uniquely identifying. This is something like a bill number, invoice number that we see, right, in the bill that restaurant gives. And yeah, so this is the logical model that we created. So today we are getting into today's topic. Okay, I hope many people have joined now by the time. Let me see. Yeah, somebody is waiting. Okay, let me admit all. Okay, so we have good number of people. People are joining in. So today's topic we are starting now. So for the case study, we are going to build the physical data model. We will need to. So how do we create physical data model? So so far we have created conceptual data model, which is only dealing with the entity. Logical model data model is only, so far we identified the data elements, like what all fields minimum that we need in every table, and also the relationship we define. So now in the physical data model, we need to create actual database object. Okay, we need to physically create, so that data can be stored and processed and finally can be used for reporting. So what we are going to do today, we are going to create a table by identifying data types for the fields. For each field, we need to identify what data type is needed, what is appropriate, and is there any additional constraints that we need. So we are going to learn each one of them now. First, we are going to identify the data types. So if you see, data type is the essential, right? So data type is going to be the essential of data. For example, if you are going to store employee ID, so generally if you see it is an integer. So many companies will have 3,255, or maybe they may have 54,525 is the employee ID, employee number, right? So like that, for those kind of use cases, we can go for integer. Similarly, how many, let's say how many items are ordered, especially in our use case, if you see, we are going to build the restaurant, right? For the restaurant items, the quantity is a whole number, right? So the quantity, is it a 2 chapati or 3 chapati, or is it a 2 puris, 5 copies? So for everything, if you see, it's a number that we need. So basically the quantity field we need to use as a numeral. Okay, so we have to use it as, we need to find out what it could be. So in numerical there are different types. So integer is what we all know. Generally it stores the whole number, but the size is 4 bytes. Okay, integer type is 4 bytes. It can store, you see how big number. I think it is some 214 crores plus or minus it can store. It accepts both positive and negative, the integer. Okay, generally you can use it for IDs. Okay, IDs we can use it, or right. And if you don't need a big number, if you think that the field is going to store smaller number, it won't cross more than 1000, so then you can define that field as a small int. Okay, so we have a small int, it only occupies 2 bytes, only half of the integer bytes, and it is going to, the range it can store is positive, negative, from negative minus 32,767 to positive 32,767. Generally, you can use it to store city ID, or sometimes you can menu card, right? You may not have more than that item ID. In case if you want to store item ID, yeah, let's say they may have some in thousands. So then you can use small int to define the item ID. So there is one more thing that we have in SQL which is called tiny int. So tiny int needs only 1 byte and it can store a value of 0 to 255. It doesn't accept negative. So the tiny int doesn't accept negative value. Okay, but it can store value 0 to 255. So what all we can use? We can use human age. Our age, right? Generally it will be maximum 100, 120 we see, maximum some exceptions. Otherwise it will be 60, 70, right? So we can use this tiny int to store our field, human age, right? So or quantity also, generally if we see in order other than bulk order, probably people it will not cross 255, right? So wherever you think you need a lesser number, so it won't cross more than 200, right? So you can go for tiny int. So what is the why we are doing this? Because every byte is going to occupy space, right? So we need to be very, very careful. So you might think, today we have GBs of data, so why should I worry or think too much about it? That should not be the case, because even it is let's say 1 byte, 2 byte, in case if you think you are building a large system, very large system, where you are going to store billions of record, billions, I'm talking about billions, this makes a huge difference. Okay, so you might store billion, maybe some billion, some gigabytes of data, that one table can save space. Okay, so you need to be very careful in choosing what whole number that you are choosing, the data type. So in some cases you need to use big int, which is of 8 bytes. So you can see the number, I think it is maybe some 15 digits or so, plus or minus it can store. This can be generally used for big data kind of, for sensor ID, event ID, which happens maybe every seconds, which happens every milliseconds. So for those kind of transactions, events, you can use these ID. Okay, and one more numerical is the decimal. In case if you need, for example, in case if you are storing, let's say in a, not in restaurant, even in some restaurants they may also have snacks, right? So which you can buy 250 grams, 150 grams. In case if there is any decimal, right, item rate, right? So in case no, they may store 27.5. So for those kind of values, you can use decimal, right? So I've just given an example here, but you can use whatever decimal that you need. Okay, but 10 comma 2, if you see how we should interpret this comma 2. So 10 is the whole number, the entire, all the digits, maximum is 10, and the 2 is after the decimal, how many, right? Only 2 decimals are allowed. So we cannot have dot 523, we cannot have, it's only 5299 is allowed. Okay, then remaining 8 will be, it can go to remaining 8 digits, the whole number. Okay, so this is, I have just given a example. This is the customer table, right? So we are going to create a customer table. These are two sample customer records, and for which, for example, age, I can use tiny int. Okay, and then I think rest all are different data type we are going to see. Okay, so we are moving on to the string. String is very generic, right? So generally our name will be string, and city name. So so many other describe, we will be describing, for example, in a restaurant, color we may describe, is it a red color, or sometime we will be describing the items that are used, item name, item description. So all these fall under string. Okay, so here in SQL it is also character, right? So 1 byte is 1 character. Okay, so the maximum it can take is 8000. 8000 is the maximum character you can use. How you define? Char of 20 in a bracket, square bracket. You will specify like this, bracket, the within the parenthesis you need to specify this. Char of 20 means it can accept 20 characters. Okay, for example, names and all, what you can define? We can define char of 40. For example, some person's name maybe can accommodate names up to 40 characters. So what is varchar? So varchar is another data type in SQL which takes only the size of that particular field. For example, for if this name field I define varchar of 40, if the record is only Raja, it only takes 4 bytes. It doesn't take 20. So it is variable type, variable size. It is varying in size based on the actual data. Okay, so that is the advantage of varchar. Whereas char of 20 will always take 40 characters. For example, if I define as a char of 40, even though the character actual character is only 4 character, but it takes the entire 40 character. Okay, so that is the difference between char and varchar. Char is a fixed number of bytes, and varchar is based on the number of records, based on the number of character needs in every field, every record. And then if you need a large text, for example, in a restaurant business, sometimes you may need to you may need a field which needs to specify more than 8,000 characters. So in such a situation, you can use text field. So text, maximum can be, it's a vast number of characters it can store. And in SQL, there are nchar, nvarchar, ntext. So all these data types are similar, same thing, but only thing is it can store Unicode. For example, if you want to store in Indian regional language like Hindi, Telugu, Tamil, Kannada, right, Malayalam, all these language, if you want to store, you can go for nchar, nvarchar. Okay, so that it stores the data in a Unicode format. Okay. So now for our below example, so I can use this for, I can use the string data type for defining name and then gender, right? So I can use that. Okay, so varchar is flexible. Yes. Can I, yes, yes, that's the right answer. Yeah. So now we are moving on to the third data type. So third data type is data type, date. So any questions, so feel free to put it in the chat. I will answer. Somebody, I think, who asked the question? The question is, okay, I think it is taking some time to retrieve. The question, I think somebody was asking, varchar, is it a flexible and a variable type? Yes, it is flexible and variable type. Okay, I don't see the question got disappeared. That's okay. Okay, let me move on to the actual presentation. So now we are moving to the third different type, data type is called date. So date, so this is obvious, right? So when question, right? What time of incident happened? So what is the information, any date that if you want to store? For example, if you want to store date of birth, so we need to define that column as a date field. Similarly, time. So time, this is how it stores, like hours, minutes, seconds. Okay, so it also has milliseconds and other information which intentionally I have not put it, but otherwise this is how it stores. Okay, this part is what it stores. And in SQL, we also have one more type called date time. So it stores both date and time. Okay, it stores both date and time. So generally, if you see in the restaurant bill, so we see date and time, right? So for those situation, you can use date time. For date of birth, you can use date field, because general date of birth we only store the date, right? Or in a company, if somebody is joining, date of joining field, you can use date. So based on your requirement, you need to choose between these three. Generally these three are good enough in date. Either it is a date, or are you storing specifically time without date, right? So specifically, so like for example, if you are designing an application for movie, so movie show time, right? Show time, is it at 11 a.m. show, is it a 1 o'clock show? So for those kind of situation, you can use this time field. You can define that as a time field separately from date field, so that you can do analysis on the based on the time. So similarly for restaurant also, if you want to no if you need the restaurant, what time customer came, you can better go for date time field, right? So you so that you know what time, which day customer visited and what time he came, because the time is important. so that you know whether he came for breakfast or he came for lunch or he came for dinner. Okay. So this is one special date time we have in SQL. Okay, so date time 2. What it does is it stores milliseconds to even ninth, I think 9 decimals or so. So it's very accuracy is even more. For example, if you are building a sensor or if you are building a earthquake related some information that you are capturing, some temperature related information, right, which needs even milliseconds, that level of information, you can use this date time too. Otherwise, yeah, in a real life scenario, most of the common use cases, this is not needed. Okay. And finally, we also have one data type called bit. So wherever, let's say you have only two type of values, so true or false, right? So you can go and define that as a bit. So you store 0 or 1. So because this will only store one bit, so storage wise, it's going to occupy very less, right? At the same time, it serves a purpose of true or false. So what all are the examples that you see true or false? Whether it in an exam, you are building a school exam, right? Whether a student is pass or fail. So it's only two is possible, right? In case if that field can take only two values, then you can go and define it as a bit. 0 means fail, 1 is pass. Something like that you can define. In restaurant also we are going to define an item. Is it a vegetarian item or non-vegetarian item? So what I can store, I can say, I can create a field called is veg. So I'll put 0. 0 means non-veg. 1 means veg. Right? So it's only two possibility, right? Whether it is a veg or not. There is no intermediate value. There is no third value. So in such situation, I can go ahead and create that field as is veg field with 0 or 1 value. Okay. So that is the data type. So now any question on the data type? So I just wanted to pause a minute here. Yeah, bit is available. So what else that you need? Only bit is available in the sense anything else that you expect? There is no bool type here. I think a bool is also available. You can try that out. True or false. Yeah. Boolean, right? So you are asking about Boolean. Yes. Okay, I think the first question Vasu asked varchar is flexible. Yes, and can extend to accommodate actual name or entry. Yeah, so thank you, Vasu. So Vasu, the question is yes, it is flexible, but it has a limit at the same time. For example, we need to define what is the maximum value. For example, if you say varchar 100, then it can accommodate, it's very flexible and it can accommodate only based on the actual value, but it cannot exceed more than 100. The upper limit is fixed, but within that it is flexible. Yeah. So now the question comes from Indu is what to do with the mixed text and number. For example, employee 001, emp 002. Yeah. Thank you. Thank you, boss. So the question comes from Indu. It is what to do mix text and for example employee number, most of us will have emp 001, right? So you go for a string. Okay, as Ganesh responded, you go for a string. You say emp 001. That will allow both the numbers because in that situation the it is not treated as a number. So emp 001 is not treated as a number because it is expected to be treated as a string only, right? For example, if you are having an order number is 0 ord 001, for example ord 0001, let's say you have. So there the 0001 is not a number actually. In the sense it's not, you don't want to do addition subtraction with that. You are not going to treat that as a number, whole number. You are treating as a part of a string. So if a number is part of a string, it has to be part of the string. Okay, so the data type has to be defined as a string. So you can define either it is a varchar 20 based on your requirement or char of 20. So does that answer your question, Indu? Okay, so I hope now you guys understood. So now we are going to go to the presentation. Thank you for the questions. And now I'm going to move on to the constraints. Okay, so before we move on to the constraint. Okay, so let's finish constraints also. Then we will go to the actual learning. Okay. So now when you define a table, we also need to give, so we can also put some checks and balances. Okay, so what all are the valid values that any column or field will allow? It is always better, right? So when you define the structure, you say that this particular field will allow this kind of values, this particular field will not allow this kind of values, right? So that this is, you are building a robust, it doesn't, yeah, it prevents bad data getting inserted. That's the whole idea of defining constraint. The constraints will protect the database from not allowing bad data or the invalid data. Okay, so in database, you guys know null value. So null means unknown value. For any unknown value, you can insert null into the record. Okay. But there are certain fields, if you think it cannot accept null, it has to have a valid known value. Then you can define that that field as a not null. For example, you cannot have a name field with not null value. We cannot insert null. Instead of Raja, can we have null? So customer name, there has to be a valid customer name. Then only it makes meaningful, right? So you can, when you define the table, you can define name field as not null. Okay, so you can define the name field as not null, so that by mistake, if anyone try to insert null, then the system will throw a valid error message. It says it doesn't allow null. Okay, so null is more of an unknown value. For any unknown scenarios, you generally insert null value. Second is a default value. In case if the value is not provided, then the SQL will automatically insert the default value. Okay, so this is one feature functionality wherein if you don't while populating the data for a field, right, you can define a default value. For example, if the restaurant is working in Chennai, so most of the people will be coming, they are coming from Chennai only, right? So when you create a customer table, customer field, if the customer is not providing, then you can put Chennai as a default location, right? So default will come handy there. Okay. And now we are getting into the interesting constraints. So unique constraint. So we have a unique constraint, unique key constraint. So unique constraint does not allow duplicate value. So we cannot have two names are the same. For example, names can be duplicate, but the serial number cannot be duplicate, right? Because it has to be unique. So in such situation, you can go for unique, but the unique will allow one null value. Only one null value it will allow unique. Okay, so it will allow one record to have null value. Then the other record also it cannot have null value. So the unique for unique. Hello, somebody asked a question. Okay, so yeah. Okay, so oh, the network is not visible. I think I see. Okay, so because my signal it shows full. Let me see. Okay, now is it? Am I audible? Hello, am I audible now? Can someone confirm whether you are able to hear me? My screen is not visible. Okay, I think the screen sharing has gone. Okay, let me share it again. I'm sharing the screen again. Yeah, let me share that window. Okay, let me share only the specific screen. Okay, so you guys are able to see it now. Can you also hear me? Okay. Okay. So now let me repeat from constraint. I think for last 2-3 minutes, looks like I think my audible, my voice is not that much audible. Let me restart with the constraint. So we all understood the data type, and now we are moving to the constraint. Okay. So constraint is uh, the constraints. These are the various constraints that an important constraints that we have, and the first constraint is not null. So in SQL, something called null. So null value means unknown value. If some value we don't know, we can use the null to store that as a unknown value, to specify to SQL that this value is not known. For example, if we don't know date of birth of someone, then what we can do, we can store this value as a null. Okay, but we cannot allow null for all the fields. If some of the important field like name, we cannot have null. For example, we cannot have null, right? Unknown value, we cannot store a customer. So what we can do is we can specify that field is a not null type. So when we specify it as a not null, then the system will not allow null value. Okay, it will throw an error message when you try to insert null value. Okay, similar, the next constraint is the default constraints that we have. So the default constraint is, for example, if your restaurant is in Chennai and most of the customers will be in Chennai, right? If they don't provide their city, you by default you can put Chennai as their default value, default location. So like that, if you don't provide any value while populating data, the system can replace with a default value. So that is the constraint, default constraint. Third is the unique key. So unique key is not going to allow any duplicate record. Okay, for example, the serial number is going to be 1 2 3 4 5 6, right? So it will not allow the any duplicate value. And but the unique constraint will allow one null value. The unique constraint will allow one null value. Okay. And the next is the primary key. Primary key is similar to the unique key, but it will not allow null value also. Okay. So basically primary key is nothing but a combination of not null and unique key. So that is what the primary key is. So most of the table, right? So it is better to create primary key, uniquely identifying record, so that it is better for from the database point of view. Performance also will be better, and also there won't be any bad data entering into the system. And third is the check constraint. Check constraint is going to allow only valid list of value. For example, if I have a gender field, I can only accept male, female, or probably I can accept the transgender or not, don't want to disclose, right? So only these 4 values we can keep. So then I can create a check constraint wherein I will give only these 4 valid values. So whatever value that gets inserted for the new record, it has to be one of these 4 values. Okay, so the check constraint will validate against a valid list of values. And then we have something called identity. Identity is more of a auto numbering. So it is going to automatically insert the value. We don't need to specify give the value. For example, if I insert third record, if this value is 1 2, then system will automatically insert number 3 for this particular field. That is what is identity. Okay. If we define a field as an identity, the SQL will automatically auto number generate. Finally, we are going to see the foreign key. I think we have already seen foreign key logically that we have seen, right? This is primarily for referential integrity. So we are going to see all of them today. Now we are going to have a hands-on session. So before hands-on, we are going to see what is the syntax for creating table. So the syntax for creating table is create table, okay, and the table name. So create table is a keyword followed by a table name, okay, and then we are going to specify one by one the field or the column that the table is going to contain. For example, if you have a customer table, create table, then customer is the name of the table, and then here you will start with maybe customer ID, and then integer is the data type. What is the data type of this particular field? It is an integer. and then this is the primary key. If I want to create this as a primary key, I will create this, mention this as a primary key. And then next is the name. Then name is basically varchar of 40. I will just specify varchar of 40. Okay, there is no constraint, but there is a constraint. I want to say not null. So like that I can keep defining this table column. Okay, so we are going to go to the hands-on. Now we are going to create these 5 tables. As part of our case study, we need these 5 tables, right? So I'm going to show you creating first table, and then all other table I'm going to show you the syntax. Okay, let me share the SQL window now. I'm going to go to the SQL Management Studio. Okay, so now you guys can see the syntax of table creation. Okay, so the syntax is, so I think we have seen what is the use restaurant DB, right? So this is the setting context. Okay, oh, you are not able to see the screen. Okay, so now can you guys see my screen? Okay, okay. Okay, so now I'm sharing the SQL Management Studio screen. So this is the screen that no, we went through on the first day to get familiarized. This is the client tool that we are going to use from today onwards. Okay, and how to interpret basically just for the people who have joined newly. This is the object browser. So like internet like we have the file explorer. This is like an object explorer. We are going to create. We have created a restaurant DB as a database for doing this case study, and this is the query editor. Okay, where we are going to actually type the query that we are going to write. Okay, so here I've created a syntax for creating a new table, and the use database is the context that there are many databases, right? So we need to choose which database, under which database this table needs to be created. Okay, so I've given restaurant name, so I'm just executing this so that the context is changed to restaurant DB. And now this is the syntax for creating a new table. Okay, create table and the table name. So I've already created the table. So that's why this, no, I'm sharing. So I don't know why this is keep going. Okay, let me share the entire screen then. So I think, I don't know why you guys are not able to see. Okay, let me know in case if, okay. So I'm working from a different location today, so that's why I think we are facing the bandwidth issues today. So I hopefully from tomorrow onwards we will not have this issue. Okay, so I'm going back, and this is sharing the syntax for create table. So create table and the table name. Since I already have created this table, that's why it is showing this object already exists. Okay, otherwise this will not throw this message. And I'm creating as a restaurant ID. So the naming convention, it is better to always prefix with the table name, or you can create simply ID. So you can also create a name like ID. You don't need to specify restaurant. But for my better understanding, I always create like this. And then this is a data type followed by name followed by data type. It's an integer, and then primary key. So I'm saying to SQL Server that this. Okay, let me also stop my video. I think that might eat up a lot of bandwidth. Okay, so okay, stop sharing, and I hope my video. Let me stop my video. Yes. Okay, that might eat up a lot of bandwidth. Okay, all right. I think now you guys can see my screen. Okay, I stopped my video also, and now rest first column, and then first column's data type, and then primary key. Okay, and then second field, and then the data type. So here I've used varchar of 50. So this will allow up to 50 characters, like a restaurant name. Okay, and this has to be a not null. I will not allow any unknown restaurant name with the value of null. And then restaurant locality, it's more of, for example, within a city what area this is, because generally restaurant will be in different areas, right? So if you want to store, you can store that. And then I am also creating, okay, what is the restaurant city, which city this is, right? Because I mentioned this is a chain of restaurant, right? So the chain of restaurant means within a city it might be in different locality, and this also might be in different cities. And I am just creating one more field called opened since, when this restaurant was opened. Okay, so this is since 2000 this is operating, and then how old is this restaurant, just I am capturing that information also. So this is the structure of restaurant table. And then I am also creating, similarly I am creating customer table, right? So the data, let's not worry about it today. So this we will learn in tomorrow's, right, how we are going to populate the table. So but right now just understand, only I am only capturing three field: customer id, and then customer name, and mobile number. Mobile number can be null. Okay, somebody, they don't want to give, but no, I just want to put it this way for our case study. And then I will be creating customer table, and then I am creating menu item. Okay, so I am creating menu item table. Okay, so menu item table that I am creating with so now here you see the other constraint. So right here we have the primary key constraint, this field as not null. I am also giving check constraint. Check constraint is this item type. I am creating one field called item type. Okay, so this item type can be of tiffin or snack, starter, meal, main course, combo, dessert, beverage, and sweet, right? Continental, if it is a totally a different continental. So like that I am providing the list of valid values. The item can be only the item type. So any item can be part of only these item types, we cannot give, right? For example, if I say idli, then I will put it as tiffin. If I say North Indian thali, then I will say it is a meal. Okay, so like that if I say coffee, then I will mark it beverage, right? The item name will be coffee, and item type will be any one of this. I cannot create an item with item types which is on which is other than this. Then I am also creating, mentioning whether this item is a veg item or non-veg item. Okay, so I am saying is veg flag bit. Okay, so I can use this to define whether this item is a veg item or non-veg item. Then the item rate. Okay, item rate I can capture it here. Then it will show in the menu card, right? As per the menu card item rate, I can keep it here. This item rate I put no, in case if they want to specify some no mixtures, those kind of items. Sometimes they'll say 250 gram. Okay, this price 100 rupees per 250 gram. For example, two idlis, right? Item rate sometimes for two idlis, then this is item price. So in that situation, you can use what is the quantity, right? Rate per. Finally, we can also say this item contains. In case of combo, for combo, you can say, okay, two chapatis and then one coffee. This is one combo. So we can also say, okay, this item contains, this combo contains these two items or these three items. If you want to specify, you can mention it. Okay, so this is how we can create menu card. And then item order header. So item header, we can create it this way. So now this is the interesting part, right? So we are going to define as a foreign key. Remember the referential integrity. So the order in which you need to create table is, first you need to create the restaurant, you need to create customer, you need to create the menu card, because those three are the master tables. First you need to create the master tables, then you need to create the transaction tables. Okay, so now the transaction table, when you create order id as the primary key, and then you create restaurant id as a foreign key, right? Because we are enforcing. So this is pointing to the restaurant table and restaurant id primary key column of that table. So this is the primary key of restaurant table, right? So that is what you can specify. So the foreign key can reference primary key of another table. Similarly, customer id has to be a valid customer from the master customer table, right? So master customer table, and then this is the primary key of the master customer table, and then finally order date. So I'm keeping this as a date time so that date and time both can be captured it here. I am moving on to the final table of the day, so which is going to be order item. I am creating order item ID as the primary key. Order ID referencing to the order header, primary key. Okay. Item ID is pointing to the menu, right? So the menu item, and then its primary key. Then I create item rate. Item rate I am keeping it here. Okay. And then item quantity I am keeping it here. How many item quantity? Then item amount. Item amount also we can calculate and store it here. Okay, so item amount is nothing but rate into quantity. Okay, so now how I can create this table? I can create the table by executing this command. So highlight this and then press on this execute. This is how you create this table. But now the table is already been created because I have already created the table. Okay, otherwise this is the syntax that you will be creating to create the table. So once you create all these 5 table, what we can do, something called, we can generate a database. Okay, so you can create a database diagram. I'm going to create a database diagram. I'm going to pull all the table that are needed: customer, item, order item, and restaurant. These are the 5 tables that we have created, right? So I'm only pulling those table. So now we will see the physical logical model diagram, physical data model that SQL is generating for us. I'm going to show it in a full screen. Okay, I'm going to show this in full screen. Okay, so here we see, so we are seeing this is a menu card. So this order item is referencing to the menu card, right? This is a relationship, right? So this is the order item is referencing to the menu card item. Similarly, the order item is also referencing to the order header, right? Because this is the relationship, and order header is referencing both customer and restaurant. So this SQL is generating a physical data model for us. Once you define the tables physically in the database, because we have created foreign key, so system knows the relationship between the tables. So in Microsoft SQL Server, you can generate database diagram for the given selected tables. Now I selected these 5 tables. I clearly see the relationship between these tables. Okay, so that is what we have seen. So now we have generated the database diagram. With that, we have come to the end of today's learning. It's a quiz time, so get ready. So before going to the quiz, anyone has any question on constraints, data types, or the database diagram that we have generated, or syntax of the table? Ask in the chat, or you just unmute and speak. So I see somebody has asked a question. Let's see, is there a question? Okay. So some question has come up from Bhuneshwari. If we have not null constraint in the column should not have a null value. Yeah. Yes. It's not an empty cell. Yes. Yes. It should not have an empty or unknown value. That's right. Your understanding is right. Okay. Looks like no one has a question. So we are straight away moving on to the quiz. Okay. So anybody is having a question? Difference between primary key and unique key. Yeah. So the difference between primary key and unique key is both will not allow duplicate value. Okay, that's the commonality between these two. Both will accept only the unique values. But the only thing is, unique will accept one record with null value, whereas primary key will not at all allow null value. That is the difference between these two, Gopi. So the difference between primary key and unique key is primary key will not allow null value even for one record. Okay, and then why we are other question from Gopi is why are we using primary key for auto increment? No, it's not auto increment. Primary key we can use identity for auto increment. I have not used it, but we can use identity field. Let me explain about identity. Okay, Go is basically to is a more of a batch, to define batch, right? Yeah, Go is more of a end of this statement. We clearly say tell it to the SQL that. Okay, let me move on to the this thing. Okay, so Go is basically to differentiate in a batch, right? In a general batch, you write a Go statement, right? Otherwise, sometimes this will create a problem. So you can use Go or you can use semicolon to say end of the line. So end of the statement is semicolon, end of the batch of statements is Go. So generally people use Go saying that this is one statement, batch of statement, and this is another batch of statements. Okay. And then the next question is, yeah, when we need to use bracket. Okay, so this is a statement. For example, the parenthesis we can use it for defining a set of statement. For example, table is going to have the set of fields, right? So the syntax is create table, table name, and then open parenthesis, then list of all the column, all the fields with a comma separator. So you see end of the we say comma. So that which means this is the first column, second field, third field, like that. Finally, once you finish all the field, you need to close it with close parenthesis. And also you use, let's say decimal means it accepts two parameter, right? So we need to specify 10 comma 2. Since it accepts two parameter value, so we need to specify. And I think for table header we have seen, right? So somewhere, yeah. And this varchar also we need to specify the width. So it accepts with a open parenthesis and close parenthesis. Once you start programming, now you will understand it becomes you will become familiar with it actually. Don't worry about it, Prabhakaran. So that is where you use temperature comma degree. A one column name. Oh, one column name. You why do you want to use temperature comma degree, right? So you need to use two fields, right? You cannot use temperature comma degree. Can I have a column name with comma? No, you cannot have a column name with comma. Column name, you cannot use comma. System will throw error message because that is a key field in the. If you specify temperature comma, then system will throw error message saying data type is not defined, because comma means end of the definition of the column, right? So temperature is a column name, but it does not have any data type, so system will throw error message. We cannot have comma for a column name. Okay, so with that we are going to the quiz. Get ready with answers. So like as usual, mention with a question number also when you answer. Don't simply put A, B, C, D. You say 1A, 1B, 1C. Data type does not allow negative number. Do you remember which data type does not allow negative number? Is it big int? Is it int? Is it small int? Or is it tiny int? Okay, I think you guys are bang on. 1A, tiny int is the one. Tiny int accepts only values from 0 to 255. Only accepts positive values. Okay, the second question. Constraint allow null value. Which one will allow null value? Only one here it will allow null value. The other three will not allow null value. Is it foreign key, primary key, not null, or unique key? Yeah, 2D. Absolutely right. Yeah, you guys are great. So then third is which data type to use for login time. So let's say what time an employee coming into the office, what time is going out from the office. It's more of login time when you logged in into the system, computer, log out from the system. Do you define that field as a date or date time, time or in time? Yeah, 3D. 3D, you guys needs to, I think whoever put D, just see whether do we have a data type called in time. I don't think we have a time data type called int time. Okay, so 3B I saw some people put, that's the right answer. For any field wherein you want to capture both date and time, you have to go for date time. Okay, and the last question. So last one you need to really go through and understand the syntax. This might be a little hard, because many of you are seeing the syntax for the first time. For creating table, what is the right syntax? Is it create table name and then table and then list of fields, or create table as a table, create table with the table name and then list of fields, or create the table name directly? Let's see whether. Okay, I think no, I see that you guys have did an excellent job, right? Even for this one, yeah, that's the right syntax. Create table followed by the table name, followed by the list of fields in a open in a between parentheses. Okay, so that's the right answer. Okay, so we have come to the end of today's presentation, and we have seen how to create physical tables. Okay, how to create physical table and how to generate physical database model diagram. Okay, so we have seen that. Today we have seen what is the data type and what is the constraints, various constraints, right? So thank you so much for joining in for today. I really appreciate your time.